So now we have comparison of properties of cis, geometrical isomer and trans. So let's see, if we have a cis isomer here and we have a trans, so let us compare dipole moment of these. So dipole moment, what do you think, is a vector quantity. So if we compare CCl, so dipole moment is drawn from less electronegative to more. So dipole moment for this bond could be drawn like this, mu1, and dipole moment for this could be drawn like this, mu2, right. So you can see the vectors are getting cancelled out. For this you will draw like this vector, mu3, and for this you will draw like this, mu4. So this vector will cancel out this vector will cancel out these, because they are exactly 180-degree opposite to each other. So vector sum is minimum out here. So I can say mu net for trans equals to 0, whereas if I draw vectors for here, for this bond mu1 and this bond mu2, and for this bond mu3 and this bond mu4. So you can see the vectors are getting added up, mu3 and mu4 will add up. Similarly, mu2 and mu1 will get add up. So mu net is not equal to 0 for cis, mu net not equal to 0 for cis. So in trans mu net is 0, in cis mu net is not 0. So dipole moment is more for cis and less for trans. Alright, next point is stability. So as we have discussed that in cis the repulsion between same groups is more, because bulky groups come on the same sides. So repulsion is more, so stability is less in cis and more in trans. Bulky groups are in opposite directions. So stability is more in trans and less in cis, right. Dipole moment for cis is more, stability for trans is more, melting point for trans is more, because it is symmetrical. Next point is solubility. Solubility is more for cis. Why is that so? Because cis has a greater dipole moment, so it has more polar character. So more polar, so it will be more soluble in polar solvents. So more solubility will be in aqueous solution for cis isomer, right. Next we have taken an example which is malic acid. Malic acid is a cis isomer and fumaric acid is trans isomer for malic acid. So you can see intramolecular hydrogen bonding has been observed in malic acid. When you heat it up to 150-degree, it will undergo dehydration and we will get anhydride of malic acid, and that will be called as malic anhydride. So dehydration of malic acid gives us malic anhydride. Now if we see that fumaric acid, can we get the anhydride for that? The answer is no. First fumaric acid is heated, which converts fumaric to malic acid, and malic acid needs heating more to get converted into its anhydride. So malic acid can be directly converted into its anhydride by heating, because it is a cis isomer, whereas fumaric acid, this is malic acid, it is a cis isomer, so on heating it directly gives malic anhydride, but fumaric acid will be first converted into malic acid. First on heating fumaric will be converted into malic, then malic will be heated to convert into anhydride. So fumaric acid will also give malic anhydride. So this is what we have to discuss on isomerism, that shows geometrical isomerism. That's it. Thank you.